Alright, so here we are with Unit 5, Lesson 3, and this really is just going to be two slides, but don't let that fool you because it is tricky. We're going to be doing a couple of conversions. On this slide, we're going to be converting from moles to grams, and on the next slide, we're going to be converting from grams back to moles. It is the same formula for both. You're just going to have to rearrange the formula by cross multiplying. So let's take a look at this one here. You'll notice it says how many grams. So whenever a term is preceded by how many, that's obviously what you're looking for. So the how many grams, of course, would go here. That's what you're looking for. That would be our x. 40.5 moles goes here. And then we'd have to find the gram formula mass of H2SO4. And we already know how to do that. Let's quickly run through. Let's do red. Okay. So let's do the gram formula mass. So we have H, S, and O. And if you look at the formula, we have two H's, we have one S, and we have four oxygens. Now you're going to go to the periodic table and look up the atomic mass of each element and round it off to a whole number. So the atomic mass for hydrogen is 1, the atomic mass for sulfur is 32, and oxygen's is 16. So we're going to do the multiplication. This comes out to 64, this comes out to 32, and this comes out to 2. So you have 32, 64, and 2 is 98 grams in a mole. That is the gram formula mass. So now we have everything that we need to plug into the formula. So we have the number of moles is 40.5 moles. We don't have the given mass, that's what we're looking for, but we do know the gram formula mass. It's 98 grams in a mole. So in essence, we end up cross multiplying because we want to get x by itself. So cross multiply, just put this over 1, cross multiply, so you get x times 1 is x, and then you end up with 40.5 moles times 98 grams in a mole. And I believe you get, and I could be wrong, 3,970 grams. This is the third time I've done this slide, so I'm trying to remember it from before. It might be off a little bit, but just double check it. All right, same kind of question, except instead of H2SO4, we're doing SO2. So I'm just going to quickly run through. The gram formula mass for SO2 happens to be 64 grams in a mole. This is something we already did in lesson 2, so you should be able to do this. So let's plug the numbers in. I have 0.75 moles. The given mass is what we're looking for, and the formula mass for SO2 is 64 grams in a mole. So we end up putting this over 1, cross multiplying, and you get x equals 0.75 times 64, so I believe that's going to be 48 grams of SO2. So that's converting from moles to grams. So let's do the opposite on the next page. Grams to moles, same formula, but we'll have a different number. So in this one, you're going to notice that we have, it says how many moles. So remember, whatever's preceded by how many is what you're looking for. So we're going to be looking for this, which is easier because then we just have to divide. So let's calculate the gram formula mass of this. So we have the gram formula mass. We have sodium is Na, O, and H. You'll see that we have one of each, which makes it pretty simple. So that's 23, 16, 1, comes out to 40 exactly, 40 grams in a mole. So let's plug our numbers in. So we have moles, which is what we're looking for, equals our given mass, which is 4.75 grams, over 40 grams in a mole. And I believe you end up with 0.119 moles of NaOH, right? Top number goes in the calculator first, so you should see, obviously, it's going to come out to a small number because the much bigger number is on the bottom. All right, so if you look at the bottom one, I'm going to go through this quickly. So moles equals, we have 39 grams. The formula mass for this, I believe, is 26 grams in a mole. So we end up 1.5 moles of LiF. And that is it for grams to moles and moles to grams.